everybody. I think it's only just the morning. Thank you very much for having me. I'm honored to be able to speak at this event. It's a great pleasure to speak in front of so many people and witness the passion that we've seen. I say earlier on from the very young gentleman, just going through the passion that they're sharing in schools for fire protection is absolutely superb to see. So thank you for that presentation earlier. Now, what I'd like to show you is how we're dealing with the AI aspects. This was mentioned earlier on by the Lord in regards to how AI is forming how we now deal with fires on a grander scale, how we take information from solutions, and how we use those insights to help us to predict fires and also put those fires out. So as an introduction, I'm Richard Pearson, the Chief Product Design Officer at Omnicom Sipca, and responsible for our Omnicom platform, which is an IOT-based platform dealing with fire, ELV, and everything that can be digitized in this world. So let's first go through the challenges. There are a considerable number of challenges when it comes to how we deal with solutions of the fire nature. It's a complex business. All new systems are not in place across a large majority of the buildings. Therefore, there is a vast amount of legacy buildings that we have there. There's huge buildings associated to siloed infrastructure. Even customers that have 10, 12, 100 buildings, they're typically siloed off, independent fire alarm systems for those specific buildings. So linking those legacy solutions together is a complicated matter. It's not an easy process. Fire alarm systems don't tend to have your standard BMS or OMVIV CCTV type connectivity. There's a lot of manual response with your standard fire alarm panel. When you have multiple buildings, multiple fire panels, multiple security teams in place, it becomes a very manual, intensive process to monitor everything. The heavy lifting is having to be done by humans rather than a solution carrying out those actions for you. This can lead to delays. It can lead to humans not understanding what alarms have been received. It can even lead to problems where they don't understand the troubles that are on the fire panel, so the risk that's associated to a fire panel having troubles. And this can all lead to limited visibility. The whole picture of the building is not being seen when you concentrate just on a fire system. So challenges that we have in this country are humidity. High humidity at certain times of the year that cause risk to buildings. False alarms. False alarms are a huge problem within every single country around the world. And if they're not managed, people begin to not listen to fire alarms. They begin to ignore the fact that the fire alarm is going off. And this creates a massive challenge when it comes to educating people to exit the buildings. Therefore, if you do not have visibility of how your system is running, you cannot build up a risk profile for that building. You cannot persuade people to leave the building if you don't understand how the building is working and all of the risks associated to it. As we know, in this country, we have fantastic rules and regulations in place. Lots of other countries don't. We have the unified codes. We also adhere to NFPA 72, for example, for our fire systems. NFPA 915 for our remote reporting. Again, I'll come on to 915 a little later on. But all of these can be very time consuming. When you have to try and pull information from a fire panel that is placed on a wall with one or two keys to press, it becomes very hard to get the tangible information from a fire panel at your fingertips, let alone get that in a report which you can submit to civil defense as to why this building had a particular fire or why it had a trouble. So a huge challenge that we have today is getting access to the data in all of the smaller fire panels that we have installed across our portfolio of buildings. And we need to change the way that we're working at the moment from a reactive to a predictive solution. We want to be able to understand the risks associated to the building, and we want to act on them before they happen. And that's something we cannot do with your standard legacy systems that we have at this moment in time. Now, what does the role of IoT, AI, as well as machine learning play in this field, in this fire field, which is absolutely critical? Now, fire sensors Again, we have to distinguish all of the different fire sensors that we see. Obviously, we had a fantastic presentation from CI Global in regards to a plug that can help stop fires at source. That is an IoT sensor. That is a device which we can take information from. We have Gent fire alarm systems. We have NAFCO fire alarm systems. We have our own Simplex fire alarm systems. There are all of these different models of fire alarm panels which we need to connect together. And the role of IoT within this space is to connect all of those disparate systems together, regardless of what it is. It could be an old legacy fire panel with an old output. We can take that information into our gateways and we can display it within a centralized platform. We can integrate into BACnet solutions, into Modbus solutions. We can connect to wireless infrastructure fire alarm systems. And all of that information from all of these IoT sensors can be collated in one place and reported on in real time, which gives us the insights that we need to be able to effectively manage and run the buildings for fire prevention. As I mentioned, we're compliant with NFPA 915. Again, 915 is a remote monitoring certification which allows us to place a gateway within a fire panel, and a single person can then go around each of the detectors and make sure that we have seen every single detector which is inside that building. Now with Omnicon, we do that all the time. When your sensors are connected, when your fire panel is connected, when your plugs are connected, all of these devices are being checked in real time continuously. So we know the status of your smoke sensor. We know the amount of smoke that's in the chamber, the sensitivity that that smoke sensor is running at, what dirty level that sensor is running at. We know from the heat detectors how hot those heat detectors are getting. So we can then start to predict curves to say when a specific sensor goes into a dirty state or will go into a dirty state. So all of this monitoring and control that we have allows the entire system to be run from one centralized location, understanding how every single sensor within the building is behaving. We have model detections. So as I mentioned earlier on, we have machine learning technology. Machine learning technology that understands how specific sensors should behave throughout the day. A good example of this is, again, humidity. We see large amounts of humidity in the evenings here in certain months of the year, and that can cause smoke sensors triggers. In other words, it sees grains of moisture or it sees droplets of water within the smoke sensor, and it will go into a failed state. It will go into a trouble state, and it will set the fire alarm off. And again, if we have too many fire alarms, as we said, this is another problem that we come to. People are going to ignore the fire alarm. So we can start doing some clever things. We can start predicting when a sensor is going to go into a troubled state and it's going to cause a fire alarm, because we can physically see the sensor quality or the sensitivity of that sensor with its dirtiness level. If we have connected weather stations from our BMS systems within the same building, we can actively change the sensitivity of that particular point or even disable it if we know we're going to be above a sensitivity level or a humidity level that's going to trigger that sensor. So any of these anomalies which are occurring, we can get the system to take the action for us. So we don't have false alarms at 2 o'clock in the morning, 3 o'clock in the morning, evacuating entire hotels, which is not a pretty sight, especially when you have to ground 50, 60 lifts within your hotels and everybody has to walk downstairs. So capturing that false alarm before it happens is key to get people to trust the fire alarm solution once more. We have historical data trending. So everything that we're doing with the fire panels is trending that data to see how that fire panel is running. Now that also allows us to manage the entire fire alarm system in a much smarter way with mobile applications, for example. So we can see exactly how the PPM or the preventative maintenance is being done. It allows us to check in real time and via reporting at a single click of a button that maintenance has taken place to specific sensors. In sensors where you can remove the head, we can actually give a piece of information that says, this head was removed, this head was checked, this head was cleaned, because we can see the sensitivity level or the dirtiness level of that detector has changed. So everything which we're doing with historical information allows us to trend an entire site, and at the end of the year we can provide comprehensive reporting that says, yes, every single point on this system was checked. Every single power supply on the system is running correctly. Every single battery in my fire panel is being charged at the correct amount and has the right voltage. So all of this data trending, this large lake of data, or big data as people call it, allows us to build up profiles on exactly how every single aspect of that fire alarm panel is working. And then we come to a more important and more poignant topic, is how we integrate that data to a federal entity. How we take that data from a singular site, or 1,000 sites, 10,000 sites, 100,000 sites, and we collate the data into one place. Obviously, we have the Hassantuk programs, we have DCD, we have Wakaya, we have Sharjah with their program as well. So all of these federal programs are taking information about a common fire and a common fault. Now we can take that one stage further because of the way Omnicon is interacting to fire panels, because we're pulling out the software aspects of the fire panel. So we're connecting to the fire panel on a point-by-point basis. So we can see every single point on that fire panel, which allows us to tell civil defense we know exactly where that fire is. Not that you have a site like Cleveland Clinic, which has 80-odd panels, 7 entrances. Where does the fire team go to first? Where is that fire alarm? Where's the piece of information that's critical for civil defense to make a difference when they turn up? We can give them that information and say, the fire alarm started in this specific point. If they have mapping, and again, civil defense teams are now collating mapping for the building, so we can go through evacuation plans. So we know exactly where that point is, we know exactly how the people will be evacuating and where they should be standing outside the building. That can be linked into Google Maps for traffic analysis. Has the evacuation we've caused, or the evacuation that has been caused, has that had a detrimental effect to the surroundings of the building? So all of this information civil defense is going to need to know. You can then take it further to analyze how many people were in a specific building. Again, civil defense would love to know how many people are within a building when the fire alarm goes off. Maybe 2 or 3 points trigger. It now becomes a realistic event where you have to start evacuating people. How many people were in there? How many people have evacuated? What streets do they stand on when they evacuate? 1,000 people when they evacuate a building is a lot of people to be stood in one place. And it will cause challenges with traffic. So again, all of this information is key to civil defense when we start having building evacuations. But through IoT, through machine learning, through artificial intelligence, we can plot that information for the civil defense teams so they can see a knock-on effect and do digital twin simulations on what would happen if we actually did evacuate the building. And this is where Omnicon comes in. This is where our overall fire platform comes in, taking all of that information together, all of that real-time insights that's being delivered by the fire system, the building management system, disparate sensors, humans entering the building. All of that information comes together. And it doesn't matter what the solution is. As I've written here, that can be Simplex, Gent, Notifier, Siemens, and there are about another 50 leading manufacturers of fire panels around the world. All of that data is key for the system to be able to provide insights into how that building is performing. That then gives us the real-time alerts. Again, you want to be able to do mass evacuation of a building, so we can send that information to people we know are working within the building. It doesn't have to come from the fire alarm system. If the fire alarm system goes off and it creates a false alarm, we want to notify people as soon as possible that it was a false alarm. We don't want to have to wait until the information goes through to all of the different people who work on the floors, who are the fire officers. It's a very important job, but they have to try and get that information out. So again, when you have a solution which can give you that information in real time to say, there was a false alarm, it was a problem with the sensor, an electrical fault caused some smoke, a toaster was used that created a trigger from an outside sensor within the hallway, for example, where smoke got blown through. That information can be got out to every single worker of the building very quickly, allowing everybody to get back inside when it is safe to do so. So all of that automatic reporting, automatic notification is key to the success of how a building is being run. And again, how do we take this abroad? I mean, we're discussing here today the UAE, but fire is a worldwide challenge. We have the same challenges now across the whole of the GCC, across Europe, across America. All of the same manufacturers work in all of these different locations. So we're proud to be partners with a substantial number of these companies, so we can take this product to other countries. We can make a difference to how other countries also operate, as indeed we're doing with Saudi Arabia, Kuwait, Bahrain, and Qatar at this moment in time. So all of these solutions coming together to create federal information that can be used across the entire GCC. Now, just before I finish, I'll give you one example. So hopefully some of you guys may know the World Trade Center in Abu Dhabi. It has the tallest residential tower at 92 stories. It has ADNOC Tower, which is Tower 3. It has a fairly substantial mall, and it has a souk attributed to it as well. Now overall, they're 4 completely separate systems. And before we implemented our solution, there were 4 completely separate control rooms, manned by 4 completely separate teams of people that were only communicating together on a radio. So they didn't have the best visibility that was going on across the entire campus. So if there's a fire in the mall, in the souk, which is literally sharing the same entity, sharing the same floor space, they're not really communicating. How do we evacuate one building and also protect another one at the same time? How do we evacuate parts of Tower 2, but then not cause a problem within the souk? So now when we change this, we centralize the entire solution. So we took nearly 100 panels, 100 fire alarm panels, and connected them all together in one single dashboard. So everything now about the entire solution, the entire system, all panels, all points, is all monitored from one screen in one location. This allows the team to see everything that's going on with the building, every single trouble that's occurring, every single fit out that is going on with inside different parts of the mall, every challenge or heat that's being created within kitchens of the residential tower, so they can start to predict if something is going wrong on a holistic basis for the entire campus. This means we can start to respond in seconds rather than minutes. We've made sure that the information that we have from Omnicon is next to the CCTV system. So we have an alarm that comes in. The system knows exactly where that alarm is. That can be tied to the CCTV. Metadata is sent to the CCTV system to say, visualize this camera. What is happening at this specific location? What happened 10 seconds before the event? What happened 10 seconds after? Did some kids pull the manual call point, for example? All that can be identified very, very quickly because we're now linking these systems together to reduce the seconds it takes to respond to a fire alarm. And as we discussed earlier on, those seconds are crucial. When you miss 10 seconds, 15 seconds, 20 seconds of an alarm, it can cause a lot of problems. In fact, in public buildings here, because of the rules that we're bound by, you have to acknowledge the alarm within a 15-second period. You then get an investigation period after where you can see exactly what's going on. Now, because of our solution, we can acknowledge the alarm, we can silence the alarm, we can view the footage of that specific area if there's a camera covering it, which means we can mobilize a team very quickly to get to that location across wherever we need to, because we're also monitoring where the team is across the entire complex as well. And that allowed us to take the entire solution from 14 operating staff down to 3, while remaining completely civil defense approved. And also, just to cover the civil defense side of things, when you're dealing with a large campus, a large fire solution like the World Trade Center, like some of the very large hotels, the Grand Hyatts, the Babel Casas, the Jewel of the Creek, for example, who we have here today, those solutions are very hard to manage when you're not on site. And there are very strict rules and regulations about being able to accept alarms when you're not on site. So we have geofencing, for example, to make sure that we are civil defense compliant. The last thing that we need is somebody looking at an alarm that comes in when they're sat on the beach in Spain and going, oh yes, I'll just accept that one and I'll disable the point from my location. Those things are not allowed by civil defense, so we also incorporate that into our solution, where if you are not physically within the building, you cannot accept the alarm, you cannot disable the points, you cannot control anything, you can only monitor. Now, if you'd like to see a demonstration, we have a booth outside, or if you wanted to ask any questions at all, then please feel free to do so. We have a live demo on hand here, so we can physically show you the fire panel, removing data, how quickly that information comes in. We have the gateways here as well, so we can show you how the gateway connects to different fire alarm systems and provide and show you real-time data, real analytics, bypass information from the fire panel, dashboard monitoring, dashboard control. And I say we have our technical guys here as well, and sometimes I'm quite technical from time to time, so you can also ask me any questions about the integration, as we have been speaking this morning with the NAFCO team as well, on how to integrate their solutions into our platform as well. So yes, if you have any questions, then please come and see me about those. Now, when it comes... Oh, wait. You can ask questions now if you like. I don't know if there's anyone who wants to ask a question. You're more than welcome to. But now, what is the way ahead? How do we start to embrace everything that an IoT system encompasses? So obviously today we're talking about fire. But a building is made up of a lot more components than just fire. As I've mentioned, we have HVAC componentry. Again, HVAC can cause problems when it comes to fire. We have extraction fans, which are typically connected to the fire system. But you also want to start shutting off things like HVAC when there's a fire, because you don't want smoke being blown around. You want to be able to control it. So where you have buildings with extraction fans, the fire system can deal with that. Where you have buildings that have extraction fans and HVAC control, Omnicon can link the two together. And Omnicon can start to control how the HVAC system is working, how we're controlling air. Do we want to stop the airflow? Do we want to increase the airflow? Do we want to create positive pressure, negative pressure in certain areas? So it allows us to control that. We also have centralized access control. So when it comes to opening doors, for example, access control systems should do that. But what we can also do is instruct the access control system that no one can go back into the building with their access control cards until the fire event is over. And it's been certified that it's over, and then the access control system can be commanded to say, people are now allowed back into the building. Of course, all of that can be connected to all of the BMS sensors to check smoke, heat, movement of people, and everything else that your BMS system would have integrated to it. And all of that is done using AI. None of that heavy lifting should be done by a human being. Because unfortunately, in most of these cases, as we discussed the Grenfell fire, a lot of these challenges that we have are caused by humans. Humans sometimes do not act in the correct way to positively deal with a fire. You need something logical which knows specific ways to react, specific ways to control the building. But not only control the building, also react to how the building is performing at that given time. When a building goes into a fire state, movement of people, HVAC being left on, lights being left on, doors being left open, you can cause a lot of problems within the building. So the building needs to know how it's reacting at a specific point to safely allow everybody to exit that building. So all of the AI enhancement models that we're using, early risk detection, and also channeling people from the building outside is key to evacuating correctly. And that requires all of the systems within a building to be linked together. Another plus point of Omnicon is we have a full open API architecture. So when we're dealing with additional fire alarm panels now, brand new fire panels, brand new building management systems, brand new sensors, say like the CI global plug, which is an amazing plug, all of those can be easily adapted into Omnicon to create a full, overarching, holistic system. So now, if you do have any questions, you're more than welcome to ask if you have microphones. If not, you can come and see myself and team, the Sibca team and the Omnicon team at our booth next door. So thank you very much.